right, we still have people trickling in. All right. Oh, that's a little close. Good morning, everybody. Welcome to day 2 of Rejects. Hopefully Salt Lake City is treating you well. Little run through on this morning. We'll have some sessions until lunch. I'll be your moderator if you have questions when we get to the end, if you have questions, just kind of raise your hand and I'll bring the microphone around and make sure that everybody on the live stream and in the room can hear you. We're going to start in this morning with a deep dive, collect and process your logs on K8s with Opentelemetry with Christos Marco. Let's go.
Okay, thank you. Morning, folks. Thank you for joining this early morning session. So we already mentioned the topic. It's about collecting and processing logs on Kubernetes environments using the Opentelemetry Collector. First of all, my name is Christos Marco. I'm a software engineer at Elastic, and I have been dealing with observability for 5 years now. And since last year, I have been spending most of my time working on the Opentelemetry ecosystem, specifically on the collector and the semantic conventions projects. So before we start, a quick reminder of what Opentelemetry is. For those that are not quite familiar, we know that it is an observability framework, and I like to think of it as a set of specifications and implementations for observability. So with Opentelemetry, we can instrument our applications using the language-specific SDKs in order to start collecting telemetry signals from them. Then using the Opentelemetry protocol, we can transport them to another component, for example, the Opentelemetry Collector, which can receive, process, and export Opentelemetry data to a remote or an observability backend specifically. These signals are usually traces, metrics, logs, and profiles, and they follow the semantic conventions, rules, and guidelines. At the same time, we can have the collector running on the edge, which means that the collector is responsible for collecting telemetry data from target systems or from the edge host directly. So with Opentelemetry protocol, we can describe logs using the specific definition that the protocol provides. So for example, to describe a log, we have a specific field in the structure to put the body of the log, another one to describe the severity of this log, and we have specific space for storing additional attributes which follow the semantic conventions. And on the resource level, we can add additional resource attributes which describe the resource that is related to this emitted telemetry. And resource attributes and attributes are following the semantic conventions, and the resource log is whatever the protocol defines. So in a simplified version, the Opentelemetry protocol is a protocol buffer schema definition, which is implemented over gRPC and HTTP. So the collector is one of the most important components in the ecosystem, the Opentelemetry ecosystem, and can be used to receive data, process them, and export them to other systems. We can use the collector as an agent on the edge, as we mentioned before, and we can use the collector as a gateway in order to receive data from other components like the SDKs. So the collector consists of pipelines that we configure, and a pipeline consists of a receiver which receives the data. Then we can have one or more processors in the pipeline in order to further process the data, and then we can export this data to another system or to an observability backend. So in order to collect container logs from Kubernetes environments, we can use the collector to read the logs directly from the files on the disk, or we can use the Opentelemetry SDKs to instrument the applications and start capturing their logs. The Kubernetes documentation specifically suggests this architecture. One of the architectures that are suggested is this one, where the applications running as containers write their logs to the console, standard output or standard error, and then the container runtime is responsible for writing these logs down to a file which is stored on the Kubernetes node on the disk. This means that if we have a collector or an agent with access to this specific file, we can start watching this file and collecting the logs from this specific file. We can further process them and send them to a login backend to store them permanently. So that's exactly what we're doing with Opentelemetry Collector. We have the pods, the containers, writing their logs to var logs var log pods directory of the Kubernetes node, and then the daemon set collector that runs on the same node has access to this directory because it mounts it as a host path, and then it can collect all the logs that are written there from all the containers that run on the specific node. The collector now has a specific receiver for this job, for collecting logs from files, which is called file log receiver. So with file log receiver, we can specify which files we want to watch and which files we want to collect the logs from. It's this include section there, and we can also define additional set of operations which are performed by the operator section here. So in this example here, we can define a regular expression parser, which in this example, receiving this input on the left, will parse it using the regular expression, and it will export what is on the right side, which means that some specific content from the log line is exported to specific and stored into specific attributes like the host, the type, and the timestamp as well. Now with container logs, we mentioned before that the container runtime is responsible for writing the log from the console down to a file. But the interesting part is that the container runtimes also wrap these log messages into specific formats. So in case of Docker runtime, the log message is wrapped into a JSON struct and ends into the log key of the JSON struct. And we also have additional information like the stream, standard output, standard error, and the timestamp as well. For other runtimes like CRIO and containerd, we have other formats, and we would like to have a way to properly parse these formats and extract this information, store it properly in the fields that the protocol defines. So in case of Docker runtime, for example, we want to export the log, put this on the body of the log record, and same for the rest of the keys there, like the stream, store it as an attribute, the timestamp as well. So in order to achieve this, we can define this configuration for the file log receiver, which consists of a set of operators in order to identify the runtime properly, and then regular expressions that are responsible for parsing the various container runtimes, and some also additional parsing to extract Kubernetes metadata from the file path, which looks a bit scary, it's a bit complicated, and if somebody wants to actually interact with it, need to be really familiar with this concept of file log operators. Fortunately, this can be hidden in the Helm chart behind the preset, which means that as users, we just need to enable the preset, and then the Helm chart, when it is installed, generates this configuration and makes it available to the collector. But again, there is room for improvement there, because we would like to have support for testing this properly, and again, if we want to actually change it or support it in the future, it's quite complicated. So the question is if we can do something better here and simplify this, and the answer is yes. That's why we decided to introduce this new parser of the file log receiver in order to encapsulate this whole logic into one single component. And we came up with something like this. It's configured like this. We introduced the container parser, which can be enabled in the configuration. That configuration is the equivalent of what we saw before, the very extensive one. So it's quite simplified, and everything happens automatically by this parser because the whole logic is encapsulated there. And having a log line like this in Docker runtime, which is written in this specific file path directory, we can produce log entries that look like this, where we have the body stored properly, we have additional attributes from the tags, and we also have additional resource attributes, which are Kubernetes metadata, which are really useful to troubleshoot our applications. And yeah, additionally, this parser can also support, can recombine messages logs that span across multiple log lines, which means that in the CRI format, we have this option to write partial logs, and we can understand this by the tag, either it is P or F. So this parser can also recombine these kind of logs and produce one single entry in the end, which is really useful. And this is one specific implementation detail that led us to implement this as a file log receiver operator instead of having it as a standalone processor for the collector, because in the processors, we cannot guarantee the orders that the logs arrive. So in that case, we won't be able to recombine them properly, like to support this specific use case. So we see that file log receiver is quite useful. One question here is how we can further enrich these logs with additional signal information like context-specific information like traces, trace ID, span ID, and so on. The answer is that file log receiver cannot do much here unless this information is part of the message. But again, we need to define additional parsing patterns, let's say, to extract this information. So there is an alternative here. If we have access to instrument our applications, we can use the SDKs, the Opentelemetry SDKs, to instrument our application and start capturing their logs and emitting really nicely structured logs that follow the Opentelemetry log data model. And we can produce records that are really enriched with all these additional information that are coming from the specific context, like traces, the process that is producing this telemetry, and so on. But this comes with some drawbacks. For example, this adds extra overhead because the applications are responsible for exporting the logs over the network. And in some cases, we have seen that it can produce log duplication because we have the SDK capturing the logs and sending them to a remote. And at the same time, if you're running a file log receiver on the cluster, it will start capturing the logs as the library writes them down to the file. And you can handle this, but it's not quite optimal. So in that case, we can combine these two different solutions. We can configure our SDKs to use the standard output log exporter, which means that the Opentelemetry records are serialized into JSON. We call it OTLP JSON, and are written down to the console, and then the container runtime writes them down to a file into the var log pods directory. Then if we have a collector and the file log receiver enabled, we can start collecting these log lines there. What we will find looks like this. We see that we have a very big message here, and we can spot that we see the container runtime format being present in the beginning with the timestamp, the specific tags. Then we have something that the SDK adds. In this example, the Java SDK adds some information about the logging class. And the important piece here, the important part, is the OTLP JSON. This JSON content here is a valid OTLP record, the valid OTLP log that the SDK produces. So we can understand that if we have a way to get rid of the additional information and deserialize this OTLP JSON, we have back the valid OTLP record that the SDK produces, and we can further process it or deal with it as we want. So we can do it. We can use the file log receiver again to properly unwrap the container runtime format. Then we can process this entry with a transform processor to remove the Java SDK class information. Then we can move the OTLP JSON part to an OTLP JSON connector, and this connector will deserialize this JSON and will produce a valid OTLP log record. And after this point, we can just we can export the log record, or we can further process it into the collector. And this is how the configuration looks like in a simplified way, a simplified version. We have the file log receiver and the container parser. We have the transform processor. Then we have the OTLP JSON connector here. And in the end, the OTLP JSON connector can send the data to an OTLP exporter, for example, and send these records to, we can send these records to an observability backend, for example. And I don't know, yeah, it's a bit small, but this is what the collector will produce in the end if we configure the collector to export the data to the console. Here we see a log record, which is exactly what the protocol defines. And we have all these resource attributes here defined, information about the specific process that produces these logs. On the bottom, we have the trace ID and the span ID information, which help us understand the context that this log record was produced by. And also we have the log message here in the body. And this is exactly the record that the SDK produced. And it was serialized into JSON, written to the console, down to a file, and then the file log receiver collects that and deserializes it back and produces this valid record. which is really useful because it solves these two problems that we mentioned before, the log duplication and the extra overhead that we add on our application when we send these records over the network. So to recap this, we saw how we can use the ecosystem, the Opentelemetry, to collect logs from containers on Kubernetes clusters by using the collector to collect directly the logs from the disk, or using the SDKs. We saw the trade-offs that each option has, and we saw how we can combine these two solutions in order to get the most out of them. So now let's have a quick demo to illustrate this idea. And yeah, for this demo I have GK cluster with 3 nodes, and I'm going to install the Opentelemetry demo. The Opentelemetry demo is a sample application that consists of multiple microservices, and these microservices are instrumented using the Opentelemetry SDKs. So I'm installing the demo now, and at the same time I'm going to install the collector as a daemon set in order to start collecting the logs from the files on the disk. So let me install the collector. I'm also going to install a sample application, a daemon set that writes logs to the console. And this is not instrumented, just sends the logs to the console. So here I can see that the Opentelemetry demo is running. The pods are getting started. This is the daemon set, the collector daemon set that collects the logs from the files on the disk. This is the sample application, and all these applications are the microservices that the demo runs. Let's also forward the port of the demo, and let's go back to the page to produce some traffic here. Let's check some products to have some logs written. And so now we are interested about this specific microservice here. It's a Java application that is instrumented, and I have configured it to do exactly what we described before, which means that the SDK writes the Opentelemetry records to the console, and then these logs are written down to the disk. So let's let's check what the logs of this application look like here. So here we can see that we have this exactly that we described before. We can see the Java specific content here in the beginning, and then the rest is the OTLP JSON part, which we are interested into. Now, if we check also where this application is running code, we can SSH on this specific node and check what is stored on the disk, so as to completely understand what is going on here. So as users, we don't need to do it. We are just exploring the solution here now. So this is the directory that the application logs are written from the containers, and let's see. This is the file that the container logs are written, and let's see its content. Again, we see what we saw before in the console, and we can spot here that we have the container format adding the container runtime adding additional information. That's exactly what we need to parse. We have the file log receiver to parse it, remove this unnecessary information, and properly deserialize this OTLP JSON record here. Let's get back to the Kubernetes environment, and let's find again where this application is running. And okay, let's find the specific collector from the daemon set that will be collecting these logs, and let's look what this collector is doing. It's this one. So here I have configured the collector to send the data to a remote, to an observability backend, but at the same time to export them to the console for debugging reasons. So here we can check exactly, we can see exactly the OTLP records that the collector is producing, And this is exactly what the SDK writes. So we see that the SDK produces these records. These records make it to the file on the disk. The collector collects them and properly deserialize them. And we have exactly the same result here. And if I go to a backend, I can also see that the records make it here. So here I have the add service again, and here are the records. This is the message of the log. These are the resource attributes. And if I specifically look for specific information, I can see, for example, the trace ID here, which means that I can further correlate this log with other signals. And I have information about the process that generates these logs, cloud metadata, and so on. Compared to the very raw application that is not instrumented, that again, the file log receiver collects its logs, but then we don't have very rich metadata here. I don't have, for example, the trace ID or the span ID because the application is not instrumented. Still, we can find some metadata that the collector adds, but it's not so enriched as the previous one. And yeah, I think that's all about the demo. Okay, we still have some time. So let's get back to the presentation and wrap this up. So yeah, some next steps here in these features. We're considering of adding support for additional formats like the Klog structured logging format that the Klog library of Kubernetes produce, which is used by the control plane components of Kubernetes and other kind of Kubernetes-specific applications like operators that could be useful to support this as well. We're also working on providing better user experience in this feature, which means that the collector will be able to automatically enable the log collection based on hints that are provided as pods annotations, which means that I can annotate my pod with specific tags, and then the collector will understand how to parse it and so on. And last but not least, we would like to have support for more well-known formats from well-known technologies and have a way to package them better so as to provide the option to our users to, instead of rewriting configurations, Opentelemetry Collector configurations, to use them out of the box. And you can find some related issues here in the presentation later. And if you're interested, you can follow them. And yeah, with that, I think we are top of the time. So yeah, thank you very much. And any questions? Yep.
Is there a reason for logging everything to disk first rather than using like syslog or journald to capture everything?
In this yeah, you can also have different architectures. In the presentation, we deal with the most famous one, which is the one that I shared from the Kubernetes documentation, where the containers write the logs to the console, the most simple one, and then the runtime writes down to the disk. You can, of course, have different architectures, but that requires extra tuning. This is the most simple one, and it's the more generic one that we have seen out there that users use.
And do they have documentation to avoid things like the ingress controller access log flooding the disk or anything like that?
On the collector side, we don't deal with this specifically, but yeah, again, it depends on the use case. You can deal with it. It's another story, I think, what you are describing. So yeah, we don't include this in the documentation.
Thank you.
Any other questions?
One.
Are there any plans on converting the stanza operators to hotel processors?
So yeah, one detail here is that file log receiver was produced by the donation of the Stanza agent or library of ObserveIQ. So under the hood, the file log receiver runs the stanza receiver. And these operators are stanza operators, actually. That's a big discussion that is taking place. I don't know if this will happen eventually. Some limitations, for example, when you are deciding to use a processor, the way that the whole pipeline, the whole collector pipeline works, cannot guarantee the order, for example. So in this specific case, if we were to implement this as a standalone processor of the collector, we cannot guarantee the order. So we lose the order, we cannot recombine the message. That's why we decide to do the extra processing at first place in the receiver.
All right, this time I'll look behind me and see if there are any questions there. Nope, no questions. Well, thank you.
Thank you.
We'll have our next talk at 5 minutes after the hour.